On June 20th, 1957, a powerful F5 tornado tore through northern Fargo, North Dakota, killing 12. While a somewhat rare occurrence for a violent tornado at that northerly latitude, it was photographed and filmed by dozens of onlookers, resulting in the most well-documented violent tornado of its era. Although often overlooked in the history of violent American tornadoes, it played an important role in the development of the Fujita scale and was critical in providing empirical evidence of mesocyclone structure, of which features like wall cloud and tail clouds had yet to be officially named. Today, we will examine the conditions that caused this tornado, the lives that it affected in Fargo and beyond, and pore over Dr. Fujita's fantastic detailed analysis of the event that was, quite frankly, way ahead of its time. Also, look at these old weather graphics. I'm excited for this one. Now, in order to understand the extent of tornado forecasting in the 1950s, look no further than these two men, Major E.J. Fawbush and Captain R.C. Miller. These two Air Force weather officers were thrown into the fire when, on March 20th, 1948, a destructive tornado swept through Tinker Air Force Base, resulting in several fatalities, snapping dozens of planes in half and leaving a $10 million hole in the U.S. Department of Defense's budget that year. And while some were left pondering whether or not that tornado could have been accurately forecasted, Fawbush and Miller were ordered by Commanding General Borum to conduct an intense analysis of the atmospheric conditions leading up to the tornado. Within the next 48 hours, the two men drew connections between surface observations from other weather stations across the US and overlaid them with upper air charts, defining different parameters that could be of significance for tornado development. On March 25th, just 5 days after the initial Tinker Air Force Base tornado, Fawbush and Miller noticed striking similarities between the morning surface and upper air charts and the data they had just poured over from the 20th. Both maps showed surface lows centered in eastern Colorado. Both surface charts showed a dry line extending southward through western Oklahoma, with Oklahoma City receiving moist return flow from the Gulf of Mexico. Upper air charts both showed a large tilted trough pushing eastward throughout the day with embedded jet streaks. While the setups weren't identical, Fawbush and Miller recognized the similarities and predicted a possibility for tornadic thunderstorms late in the afternoon and evening. Once the first echo tops appeared on the station's weather radar, they tracked the storm's motion, determining that they were traveling at 27 miles an hour, which placed their arrival at Tinker around 5:30 p.m. This is when the two men issued an unprecedented tornado forecast for the immediate area, and a little after 6, a second violent tornado swept through the base, leaving it in shambles once again. It's hard to say what's more unbelievable, the fact that a violent tornado hit the exact same place twice within 5 days, or that a violent tornado was accurately forecasted at all in 1948. The forecast bulletin, which resulted in all men at Tinker enacting the tornado safety plan, putting all aircraft in hangars, and removing any objects that could turn into missiles if launched into the air, likely saved dozens of lives and millions of dollars in damages. 3 years later, in 1951, Fawbush, Miller, and Captain Starrett published an empirical method of forecasting tornado development, a landmark bulletin that marked the beginning of a 70-year endeavor by the Weather Bureau and eventual National Weather Service to improve tornado forecasting. The bulletin itself is fascinating. It compiles data from 1920 to 1949, such as the average tornado days by month in the US, and shows early indications of the relationship between topography and tornado development. Even back then, Dixie Alley contained most of the tornado occurrences between October and March, and April and May consisted of the Great Plains insanity. The most important section is the relation of tornadic occurrences to synoptic situations, and this is where the fundamental conditions for tornadoes are mapped out. Moisture near the surface capped by drier air above. The surface moisture is supplied by a low-level jet. A jet streak exists within the jet stream aloft with winds exceeding 35 knots, sitting over top the moisture-rich environment below. And finally, some appreciable lifting is needed at the surface to initiate convection. Over the next couple years, several devastating tornado outbreaks struck the US, including a multi-day travesty in June of 1953, which I'll be covering later on. This put public pressure on the Weather Bureau to push a tornado forecasting program forward, and this is when the Weather Bureau Army-Navy Analysis Center was formed in Washington, D.C., which was quickly renamed to the Severe Storm Local Warning Center, or SELS. Throughout the 1950s, data plotting and analysis was done via pen and paper, which was quite a tedious task. But with diligent work through Operation operational meteorologists, the forecast bulletin size decreased from 38,000 square mile chunks in 1952 to just 15,000 square miles in 1954. And now we can talk about Fargo. Fargo is a city in far eastern North Dakota sharing a border with Minnesota. Back in 1957, it hosted a population of 43,000. Construction of Interstate 94 had just started a year prior in 1956, and it wouldn't be until 1972 that Interstate 29 would cross north through the city to the Canadian border. So the entire southern and western side of the city, which is home today to new subdivisions and industrial parks, just didn't exist in 1957. But it was still a major city in that area. On the morning of June 20th, 1957, it became apparent that severe weather was imminent later that day. A weak surface low sat to the northwest over Medicine Lake, Montana, with a cold front stretching to the northwest, getting ready to swing down over the Midwest. At the 500 millibar level, a shortwave ridge was sitting over North Dakota, which allowed warm, moist air to build much further north to the Canadian border. A shortwave trough existed to the west over Wyoming that would swing eastward throughout the day, and an 80-knot jet streak at 250 millibars stretched from Montana to southern Ontario. At the surface, winds were blowing out of the south at 20 knots, and throughout the day, moisture would build into the area. We'll talk about that later. A surface high situated over Missouri was also aiding in this moisture transport due to its clockwise subsiding flow. By early morning, temperatures were in the upper 60s and dew points were in the 50s across South Dakota. The southerly wind at the surface beneath a northwesterly jet provided intense directional wind shear, providing substantial horizontal vorticity. This zero-Z sounding from St. Cloud, Minnesota shows the steep lapse rates, or the rapid decrease in temperature with height, but it fails to show a pocket of low-level moisture that was advected northward throughout the day. But these conditions aren't necessarily favorable for violent tornadoes. There had to be some smaller scale factors that made more favorable conditions throughout the day, and we'll get into that. It's important to note that although the SELS was making progress in their severe weather forecast bulletins for the 15,000 square mile sections of the US, the individual Weather Bureau offices did not have a standardized procedure for issuing smaller severe weather warnings. Furthermore, the forecast areas that were under the jurisdiction of these individual offices were ambiguous and poorly defined, whereas nowadays we get this wonderful map of each individual forecasting office's county warning area. Ray Jensen, who was a forecaster at the Fargo Weather Office at the time, described the less than ideal forecasting conditions in his personal account of June 20th. A sparse surface observation network, insufficient radar imagery from a defense radar 60 miles away, and no storm spotter network resulted in looking out the window, looking at your data, and making a judgment call. There was, of course, the occasional person who would call into the weather office directly with a visual on a tornado or a severe storm. Your warnings, should you choose to issue them, would be made up on the spot with no clear guidance as to what language you should use, and to disseminate this information to the public, you would use your singular phone line to call several radio and TV stations where the person on the other end would manually transcribe your warning with a pen and paper and air that information to the public. There was a system in place at the time called Control of Electronic Radiation System, or CONELRAD, which allowed the government to broadcast civil defense information directly to the public over radio stations because, you know, the Cold War. And of course, the Weather Bureau made good use of it in 1957. Upon reviewing the weather charts at the start of his shift around 4 p.m., Ray concluded that thunderstorms were likely later in the evening ahead of the existing cold front. Ray used the next couple hours to draft several severe bulletin templates to save time if he needed to issue a warning later. Now, although we don't have direct high-resolution observations from across the state during this time, there are several theories posed in a reanalysis written by Clancy J. Schultz, David J. Kellenbez, and Jonathan Finch. If you look at the surface weather observations at 12Z, you'll notice that light rain was located in the northwestern corner of the state, and at 15Z, rain developed further east. At 18Z, a thunderstorm was reported at Devil's Lake, further to the east. Elevated convection was happening along this warm front, and these storms effectively produced an outflow boundary, an area of drier and cooler air denoted by the decrease in temperature shown here. Throughout the afternoon, with clear skies to the south, the warm sector only got warmer. As this boundary sharpened throughout the afternoon, it drifted south near the city of Fargo, and as the warm, moist air backed into the warm sector, supercells began firing along the boundary. Now, when you look at this dew point temperature map, it might not make sense. Sure, the winds were blowing out of the south, and the deep south as moisture returns from the Gulf. but Oklahoma and Kansas were practically bone dry the morning of the 20th. How could moisture from the Gulf reach Fargo by the evening and not moisten the boundary layer in the central Great Plains? Well, it likely wasn't moisture from the Gulf, but rather moisture from corn. I'm not kidding. Evapotranspiration is the process by which moisture within the soil is evaporated into the lower atmosphere through plants. And in late June, approaching the peak of the growing season, corn acts like a giant straw, pumping millions of gallons of water into the lower atmosphere on hot sunny days. It even has its own name, corn sweat. And yes, evapotranspiration also occurs with other different types of vegetation, but corn is the big one here in the US. This can effectively raise the dew point by 5 or 10 degrees Fahrenheit, and with the right conditions, like drier air aloft and southerly winds at the surface, that moisture in the boundary layer can get evected or moved several states over. Here, the southerly winds likely evected the moisture northward into Fargo, as shown by the dew point increasing from 59 degrees at 1 p.m. to 69 at 7 p.m. So by the evening, conditions were very favorable for long-lasting supercells with tight rotating updrafts. Back in Fargo at the weather office, Ray noticed a line of towering cumulus out his window to the west at 5:58 p.m. The storm in question was a supercell over Barnes County to the west that would sustain itself for 6 hours and produced 5 distinct significant tornadoes. The first tornado was observed around 4:30 p.m. to the west of Magnolia, lacking a condensation funnel, picking up haystacks as it crossed County Road 10. It was on the ground for 11 miles but did no real damage. Right as the first one lifted, a second larger tornado touched down west of Castleton. This tornado was roughly 300 yards in width and cone-shaped, as shown by these photos taken from the Madsen family farm. The tornado was on the ground for 5 miles and did little more than knock down trees. This was the point that Ray observed the cumulus clouds out the window to his west around 6 p.m. Central. From here, things happened incredibly fast. Ray began receiving phone calls from the public seeking answers as to how bad the dark clouds would be. At 6:20 p.m., Ray ironically received the SELS forecast bulletin for that evening, which correctly predicted an increased tornadic potential for extreme southeast North Dakota and northeastern South Dakota. This bulletin was received right as the Castleton tornado was on the ground and was immediately broadcast over radio and television. Ray was now incessantly receiving phone calls from the public asking about this tornado forecast, to which he would just pick up the phone, say, "Turn on your TV," and hang up. Eventually, he just stopped answering phone calls altogether. At 6:25 p.m., he spotted a tornado roughly 25 miles to the west of the station, extending from the base of the towering cumulus clouds. This was the Castleton tornado, and he immediately called the air traffic control tower, who had also spotted it. Ray then quickly filled out the rest of his template for his tornado warning bulletin with specific times and areas, and used his direct phone line to read the bulletin to several television and radio stations at the time. At around 6:35 p.m., the supercell began its third cycle as it approached Fargo. E. Vernon Hendrickson was now at the station with Ray Jensen to help warn the public of the impending tornado, activating the emergency broadcast network for the city. The tornado bulletin had been seen by thousands across the area, and it inspired many of them to walk outside with their cameras to try to capture this historic event. The result is one of the most photographed violent tornadoes of all time, and it helped that the supercell was moving rather slowly, giving residents of Fargo more than an hour of lead time. As the storm approached southwest Fargo, an area near the Cheyenne River known as just West Fargo today, onlookers noticed the strange lowering of the rain-free base of the storm with a long tail stretching to the north. Some even thought that this tail was the tornado. This was the rotating wall cloud that would soon spawn the tornado. Above the wall cloud sat an incredible textbook spiraling mesocyclone. These kids in the foreground were the children of photographer Alf T. Olson, looking for frogs in a ditch as the wall cloud loomed to the west. It was truly a family affair. You can also see the air traffic control tower in the background, which really makes you appreciate the clear view and direct communication they had with Ray back at the weather office. As the wall cloud passed 2 miles to the north, a small funnel touched down, slowly drifting to the east and growing in size. This is when Hendrickson used the Conrad warning system to speak directly to the public on all television and radio stations. It was a fantastic system to have in 1957. As a result, dozens of people began evacuating the downtown area of Fargo by car, mainly on State Route 81, which would have been disastrous had the tornado been moving at a greater speed. Dewey Bergquist, a meteorologist at WDAY Fargo at the time, got in his car and headed up US Highway 81 near the railroad tracks present-day 19th Avenue North. He began taking dozens of pictures of the tornado as it headed east towards the city. The areas on the front lines of this violent tornado were the College Second and Golden Ridge editions, more commonly just called Golden Ridge. This area was where lower income families lived who worked in Fargo, and the cheaply constructed homes, many basementless, several mobile homes, all of them a death trap in the 200-mile-an-hour winds. Sometime after 7:30, the violent, slow-moving tornado shredded the southern half of the subdivision. Moving at just 10 to 15 miles an hour, it took nearly 90 seconds to cross the few square blocks of Golden Ridge, flattening every house and pulverizing every tree in its path. This footage was taken by Harry Jennings of WDAY atop the roof of the television station at 207 5th Street North in downtown. This was roughly the time that the tornado hit Golden Ridge. The individual vortices within the tornado can be seen spinning around the parent center, similar to the Edmonton tornado of 1987. Just to the northeast sat the Great Northern Railroad Yard and PV fertilizer plant, both of which were destroyed. At this point, the tornado was a pitch-black cone filled with industrial debris. It reminds me of the Heston tornado of 1990 when it hit the powdered cement factory. The slow-moving vortex was originally heading southeast towards downtown, but made a sudden turn to the northeast, which likely saved hundreds of lives. Unfortunately, North Dakota Agricultural College was hosting hundreds of high school boys for the annual FFA convention at 7 p.m. on the 20th. At 7:30 p.m., the boys were notified that a tornado was coming, and everyone dispersed to find shelter throughout campus. The tornado clipped the southeastern corner of campus, as shown by this photo taken by Elwyn Hutchinson looking over present-day Ladd Hall. The view is similar to that of the Tuscaloosa tornado seen from the University of Alabama. Along present-day North University Drive, the Silver City Faculty Housing Complex, YMCA, and Hasty Tasty restaurant were not so lucky, all sustaining severe damage. Here, owner of the Hasty Tasty, Nicholas Janakis, stands in the remains of his restaurant. The St. Paul's Newman Center and College Barbershop were also battered by flying debris. The tornado then took an unexpected right turn, now moving due east, slowly carving out northern Fargo between 13th Street North and Broadway. Homes in this area were a mess. Some were shredded into a pile of finely splintered wood. Second floors were cleanly removed from three-story homes. One house on 10th Street remained intact but was shifted off its foundation by several feet, scarily leaning to the west. Entire exterior walls were removed, exposing interior rooms like a folding dollhouse. The Sacred Heart Convent on Broadway took a direct hit, but luckily the nuns were taking shelter in the basement and stairwells and all made it out alive. After crossing Broadway, the tornado started to shrink in size, losing its continuous condensation funnel at times. The 5 blocks to the east of Broadway saw much of the same. Splintered wood from the west side was launched into parked cars, piling up in people's backyards. Portions of homes were ripped away, with the occasional complete collapse. The tornado made a classic left turn as it slowly trudged away from the city and roped out a few miles away. The city of Fargo and its residents were in immediate shock. Word got out fairly quickly that Golden Ridge was essentially gone, and first responders rushed to the area. The 12 deaths that this tornado caused were all in the Golden Ridge community. 2 deaths were from injuries related to the tornado and happened weeks later. This is where things get pretty dark. The Munson family, consisting of Gerald and Mercedes and their 7 children, lived on the southeastern side of Golden Ridge. On the evening of the tornado, it was Mercedes' 36th birthday, and she was looking forward to getting off work as a bartender to go be with her kids. Her husband Gerald was a truck driver and stuck in Bismarck for the evening. When Mercedes found out about the tornado, she raced home to find the neighborhood just gone. Her 14-year-old son Leroy was babysitting for a neighbor and was the only one that survived. To make matters worse, there were no working phone lines after the tornado hit, so Gerald found out about his children in the morning paper on the 21st. Within the story was a photograph of his neighbor Richard Shaw immediately after the tornado, carrying Gerald's deceased 5-year-old daughter out of the wreckage. It's sometimes hard to remember that even though this tornado hit 70 years ago, it affected real people just like us. And those real people had an insurmountable task on their hands of rebuilding everything that they had lost. Those with only broken windows used the splintered wood to board them up to prevent looting. The National Guard stationed at Camp Grafton headed down to Fargo to help with the recovery efforts. Some of their duties were to direct traffic within the damaged neighborhoods as well as prepare meals for those in need. Around 100 blocks of northern Fargo were affected by the tornado. As the news spread about the occurrence of the tornado, one man at the University of Chicago took great interest in assessing the tornado damage. That man was Dr. Tetsuya Fujita. Having flown from Japan to the US just a few years prior, he was brought to the States to conduct research with Horace Byers, focusing on physical processes occurring within individual thunderstorms. Having carefully analyzed the damage in Hiroshima and Nagasaki 10 years earlier, he knew that the damage caused by a tornado painted a picture of what was going on within the thunderstorm itself. So he traveled to Fargo and collected photos and films from the residents affected, and to assess the damage in collaboration with WDAY meteorologist Dewey Bergquist. Many residents in Fargo were surprised to see this brilliant Japanese man take interest in their stories. Some of them didn't even know where Japan was. Over the next 2 years, Dr. Fujita carefully crafted an unprecedented written analysis of the tornado and associated supercell, and it is one of my personal favorite research papers of all time. Within this 67-page document, Fujita outlines in great detail the synoptic setting that created all the tornadoes that occurred on that day, creating detailed maps of their damage paths, including the direction of the scattered debris. Most impressive of all, he mapped out where each photograph he received was taken, triangulated the exact location of the tornado, and ordered all the photos chronologically. The result was the first full depiction of the entire life cycle of a violent tornado. Not only that, but he then scaled the photographs, drawing by hand the other relevant features of the storm, including the wall cloud, tail cloud, color cloud, and mesocyclone. This paper helped cement these terms for supercellular structure that we now use in meteorology textbooks. To supplement this research, he also created a video animation using this contraption, which appears to be a video camera mounted above a light box with the maps being hand-drawn. In all of his animations, he uses a physical clock, so you know exactly what time these observations were taken. He included maps such as estimated precipitation and surface pressure isobars, hourly surface pressure charts showing surface fronts, and the position and angle of the wall cloud and tail cloud as they approached the city of Fargo. This one is particularly cool because he understood that a tornado itself rotates cyclonically around the parent circulation, and when it moves away from the center, it tends to rope out. My personal favorite is this Mickey Mouse Disney style animation of the tornado itself beneath the rotating wall cloud. I'm not gonna lie, these animations have greatly inspired the ones I try to make on this channel today. The forecasting for this event was a huge success in that virtually everyone within Fargo had an hour of lead time before the tornado hit. It was maybe more attributed to the fact that it was a slow-moving, low-precipitation supercell and the Castleton tornado was visible 20 miles away before the Fargo tornado formed. The SELS began using IBM 1620 computers in 1963 to perform calculations related to forecasting, which greatly improved the speed of forecasts. And Fujita went on to create the F-scale in 1971 when he officially rated this tornado an F5. It remains the strongest and deadliest tornado in North Dakota state history and one that defined the city of Fargo for years to come. Upon attempting to contact Ray Jensen while researching this video, I sadly learned that he passed away in November of last year. I'm grateful that he wrote and published his recollection of the event online, which I will link below in the sources for you to read. Also, one more interesting bit. You remember that house that was scarily leaning off of its foundation? Well, they actually saved that house and it still exists today, albeit renovated for the future. As always, if you have a personal story related to this tornado or any other event that I covered that you want to share in the comments below, please do that. I love reading them. Also, let me know what event you guys want to see me cover next, and I will see you soon.
We are interrupting this program for a special bulletin.
The Weather Bureau has announced the hurricane due to hit today has changed direction. Hurricane warnings for this area have been canceled. However, small craft warnings